So now let's transition from maintaining homeostasis to how the hydrogen bonds in water make it less dense as a solid as opposed to in liquid form, and why this helps sustain life. If you've ever dropped an ice cube into a glass of water, you've seen firsthand how the solid form of water, ice, is less dense than the liquid form, right? The ice floats. This is because of the hydrogen bonding in water, and this feature helps support life. Remember, hydrogen bonds are not very strong, and they break and reform all the time. Water molecules move around a lot, and the weak hydrogen bonds constantly break and reform. Because of this, liquid water molecules are very disordered and can pack in rather tightly or close to one another, meaning there are less empty spaces in liquid water. Now, when temperatures drop below 4 degrees Celsius, and we now start to see the formation of solid water, also known as ice, begin to form, the water molecules stop moving around. This gives the hydrogen bonds opportunity to become more stable. When stable, still hydrogen bonds form between frozen solid water molecules. It forms this hexagonal crystalline lattice structure, which you can see has many, many more empty spaces in it than liquid water. These large empty spaces are what make solid water, meaning ice, less dense and lighter than water, which causes the ice to float when it's placed in liquid water. Now, that's great and all, right? Ice floats, and now we know why, but who cares, right? Why does this property actually matter? Let's talk about it. Well, all of these species sure think that it matters. The layer of ice that forms on the top of liquid water in nature insulates the water underneath it, keeping that water that's below about the same temperature, meaning no further ice forms underneath that layer. Or if it does, this happens very, very, very slowly, so it's not detrimental to the beings below. The layer of ice that forms, therefore, helps keep the liquid water within livable temperatures for aquatic life. This is not only important for the survival of organisms that live in water, though, but it is also very important for species that rely on aquatic life for food, right? Other substances become more dense when they freeze or turn into a solid, right? For instance, solid benzene sinks in liquid benzene. Water is special because it is less dense in its solid state, and this is because of hydrogen bonds, and this helps sustain life. So now as a check-in, applying what we just went over, imagine you lived in a world where ice was more dense than liquid water, meaning ice sank in water. So new ice would constantly be forming at the surface of the water and then sink. Why would this be a problem for aquatic species? Check-in number 20. In Colorado, it can be blazing hot during the day, but then get really cold at night. Florida, by contrast, has relatively the same temperatures during the day and at night. What property of water explains how our dry Colorado climate results in such temperature fluctuations? All right,